Right, so you'll see that the title of our presentation is in fact As Old as the Hills. And we're going to talk about relief representation on maps before the 21st century. Quick summary of some of the ways people depicted relief on maps in the pre-digital age. And we're starting with this, which is a very, very early example of 3D mapping. This is the Saint-Belec slab, which was found in Brittany and dates probably from the early Bronze Age, could be up to about 5,000 years old. This research earlier this year concluded that it's almost certainly a 3D map of an area around the Ode River. So it is a bit of an outlier as regards 3D mapping. The lines and spots on it are thought to indicate earthworks and settlements, and the photo is reproduced by kind permission of the photographer Dennis Glixman. But moving on from this very early example, the earliest flat maps tended to show relief pictorially. So a picture of a hill or a range of hills, which wasn't sophisticated, but it was easy to understand for a population that wasn't cartographically literate. And this was the standard form of relief representation on maps right into the 18th century, but other more accurate and scientific approaches were gradually developed alongside it: shading, haching, contouring, layer color, and so on. So Pete and I are going to go through them roughly in chronological order, showing some examples. Actually, there was a lot of overlap between techniques, and one thing would evolve into another. And some ideas took a long time to come to fruition. Contours were first devised in the 16th century. It was about 300 years before they went mainstream. So, starting with some early examples. This is, in fact, a mid-17th century copy of an original map made in the 12th century. It shows Sicily, and it was made by the Arab Muslim geographer Al-Idrisi for King Roger of Sicily, and appeared in his geographical work, the Book of Roger. The original doesn't survive, but this is one of a few surviving copies, which is in the Bodleian. And so you can see that this very early pictorial representation of relief looks rather like little caterpillars or perhaps baguettes. And this sort of technique continued. This is the Goth Map of Britain, made in the late 14th century. So it shows Great Britain with east at the top. And it had a similar technique to show relief for the Highlands. This one is a very early map of Great Britain. It was hand-drawn on vellum, animal skin. It was really far ahead of all other maps of Britain of its time in terms of scale and accuracy. There are many mysteries about exactly how, why, where, and by whom it was made. And it doesn't show very much relief. It mostly shows towns and distances. But this enlarged extract, top left, shows the north of Scotland, for which the geography is admittedly rubbish, with sort of pictorial caterpillar type relief. I'll try and point with my cursor if you can see it. You can see these sort of little lamps, sort of little lumps, also look a bit like hedges. There's also a rather nice goat. But once printed maps began to appear at the end of the 15th century, pictorial relief representation quickly became a bit more realistic. So first on the left here, we've got a Ptolemaic atlas printed in the 1480s. So this is a map based on the geography of Claudius Ptolemy, who lived in the 2nd century in Alexandria, but this was produced much later. So these are woodcut maps revised and edited by Nicolaus Germanus. The mountain ranges, you can see quite a lot in Africa, are still a bit baguette-like. So this is the very early days of printed cartography. And of course, it's a beautiful map with all the angels blowing the winds around it. But then you look over on the left, and this is a map of Iceland about 100 years later, an extract from one, drawn late 16th century by Abraham Ortelius for his tale From August to Rama. And here the mountains are starting to actually look like mountains, although the sea monsters may be less realistic. Around the same time, we start to get more maps at a larger scale. So these are two late 16th century English representations of parts of Gloucestershire. So the one on the left is a printed map from Christopher Saxton's Atlas of England and Wales, published in 1579. And the hills are drawn as sort of separate little units in a fairly primitive style. The one on the right is one of the Sheldon tapestry maps. This is a woven tapestry map based on Saxton's cartography. And there's much more subtle technique here used to indicate the hills. And some of the hill outlines give the impression of tree cover, but there are also separate symbols used for trees and forests. Meanwhile, in China, this is an extract from the 17th century Selden map of China and the surrounding seas. So it takes a similar approach. Trees are featured largely, and they're often just as big as the hills, as happened in the tapestry map. And I think what this shows us really is that both trees and hills should be seen as symbols, which have been drawn to a convenient size. Obviously, everybody knows that a hill is bigger than a tree. And this also fits with the way the hills on many of these maps are drawn as separate little features. They're pictorial in style, but there's no attempt to blend them into the landscape. It's a symbol for a hill or range of hills rather than a picture. So this pictorial style does seem to have been quite universal. It's been used by people in 12th century Sicily, 14th century England, 16th century Netherlands, 17th century China, all addressing the same question of how to show hills on a map and all coming up with rather similar solutions. Some more examples to show how the pictorial style developed. These are both Italian. The one on the left shows the area around Vicenza around 1650. And it shows rather lumpy looking mountains, slightly as if the landscape has some sort of disease. Whereas the one on the right from the early 18th century has much more flowing mountains. Styles were still evolving and you're getting a bit of shading included there as well. This one's a bit of an oddity. It's pictorial hills shown in some places upside down to match the way the traveller is going. This is an English road map, early 18th century, based on John Ogilvy's work. And it's designed for the traveller to follow the route of the journey. So if you look at the left-hand side, you would be travelling from the bottom of the page to the top, and there are the hills the right way up. And then you started at the top and went back down again, and you can see that there are hills shown upside down. So you could turn the map around to follow the route of your journey. Obviously, it only worked in one direction, but there isn't really one way around that. This is a map of Brecknockshire from the 18th century, from Thomas Kitchen's large English atlas. This map first published in 1754. And there are lovely pictorial hills here, again emphasised by shading. So by this time, hill shading was developing, and it's more sophisticated than just drawing a picture of a hill. Generally, hill shading has the light falling from the top left, which doesn't really make sense in the Northern Hemisphere because it means that the sun's in the northwest, which it never is, but it does seem to work aesthetically. So this approach to enhance pictorial relief is aesthetically pleasing and it's also easy to interpret. By the 17th century, hashes, short lines following the direction of the slope, which began as a modification of shading, give the possibility of much finer and more accurate relief depiction. Also looks lovely. Hashing is my favourite form of relief depiction. So on the left, we have an extract from a late 17th century map of the Lazio region in Italy with pictorial relief enhanced by hashing. And then on the right, there's a map of the mid-17th century map of Boulogne, a detail showing the area around the fort. So on this one, the natural relief is shown pictorially with hashing, but the earthworks around the fort itself is shown by hashes alone. And by the mid-19th century, hashes were absolutely cutting-edge relief depiction. This is an extract from an 1830 map of Great Britain by James Walker, a transport map called Map of the Inland Navigation, Canals and Railroads. Mainly water and rail transport is shown and mineral resources. This is absolutely enormous. The original is about 2 meters long, beautifully engraved and delicately coloured. And the hills are shown by hashing, which is delicate and accurate, but also stands out well from a distance. If you look at somewhere like Buckinghamshire, where you've got Chiltern Hills across, you can see that they jump out at you a bit. And that happens even more with this 1846 French sea chart example engraved by Charles-Étienne Colin III, my favourite French sea chart engraver. Very fine hashing on the land, which makes the relief stand out almost in 3D. This also has a nice example at the bottom of the chart of a coastal view, which is a very common navigational aid that was included on charts to show how the land appeared from the sea. And of course, this is another way of showing relief. It was helpful to navigators approaching to see what the land would look like. And a final example of hashing, this is a military map of Kars in Turkey, which was besieged in 1855 during the Crimean War. So very detailed relief is shown by hashes. It was published by the Topographical and Statistical Depot of the War Department in 1856. So it was designed to be a practical map, not just a decorative one. The steep slopes are further emphasised by shading, and the steepness of the slope, especially you can see here, this was crucial to the outcome of the siege. It was too difficult to attack uphill, in short, up a slope that steep. And the use of shading continued through the 20th century and into the present day. This is a lovely colourful map of the Swiss Alps by Eduard Imhoff from 1938. It's a map of the area around the Walensee, and Imhoff was very influential on Swiss cartography and introduced this method of tinting, where the illuminated slopes are shown in yellow and the shaded ones in blue, so there's a difference in tone as well as in light and dark. This emphasises the shading as well as being attractive. Shading is also a useful way to give some indication of relief on a small scale map. This is a detail from a small-scale mid-20th century Michelin road map of West Africa. The hill shading just gives a very general idea of relief. And this extract from a 1967 National Geographic bathymetric chart of the Indian Ocean reminds us that relief isn't just on land. It's more detailed than the last one. It's also rather beautiful. And this is part of a lovely series of maps of bathymetry that National Geographic made at around this time. So both shading and hashes are attractive and easy to interpret, but more accurate and scientific techniques are possible, often involving specific heights rather than just being descriptive. So I'm now going to hand over to Pete, who's going to tell you about some of those.
Thank you, Debbie. Contours are now a standard form of accurate relief representation on large and medium scale maps. The idea is in fact very old, first used in the 1580s by a Dutch surveyor as bathymetric contours to show water depths. Contour lines joining points of the same height above a notional sea level were proposed in France from the 1770s. This map was made in 1791, actually the first hypsometric map using different colors within height zones, and it was made by Jean-Louis Dupin-Triel, as I said, in 1791. A fairly small-scale map of France, the color tints make it easier to interpret. This naturally leads to a digression about layer color and hypsometric tints, which were popular in the early 20th century. This use of contours, generally with a larger interval, and colored the different height zones between them, often illustrated by a color wedge displayed alongside. Unless done very well, it can be a slightly heavy-handed approach. Here's a War Office map of what was then part of the Anglo-Egyptian Sudan, published in 1930. This has some very subtle colors. In contrast, this rather fine OS layer color from 1908 on a 2-inch to the mile map is much stronger, and some may think a little heavy-handed. And an extract from a 1922 bathy orographical map of Oceania by W and A.K. Johnston applies the same approach, colored contour intervals, to both land and sea. This is very simple to interpret, a bold effect when seen from a distance, and was popular for school wall maps, and still is, according to my friends at Lovell Johns. Indeed, demand for such maps increased during the recent lockdown. Another early French example, this is the map of Monseni in the French Alps, was published in Paris. Our catalogue tentatively dates it to about 1820, the Bibliothèque Nationale to 1860. Notice too the use of rock drawings to show the cliffs. This is a detail that enhances the overall beauty of the depiction of the terrain. Here is a glass negative of Napoli, produced in about 1880 by the cartographer Corbellini and published by Vallardi, shows both contours and shading. The Bodleian doesn't hold a printed copy, but this duo produced several town plans at about that time. Now here is a very nice OS 1 in 50K map of Dolgello from 1985, showing Kadar Idris with contours, shading, rock drawings, and heights. This is an extract from an early 21st century Harvey map of Scafell Pike. Detailed contours enhanced by varying the color, that is grey for rocky ground and brown for elsewhere, with additional symbols to mark crags and spot heights. Other refinements of contouring include heavier lines at the 100-meter mark with thinner lines between, contours combined with shading, very effective, contours combined with elevation tints, and illuminated contours, sometimes known as the Tanaka method. The latter combines dark contour lines in shaded topography with white ones in illuminated topography, done with a light source shining from the top left. This may be more intuitive to the reader than just having colored lines, but I'm not sure that how common it is to use this technique. This is an example from Ken Field's book. Is an example of, there is an example in Ken Field's book, Cartography, an illustration of Lake Tahoe on page 228. As well as more scientific approach to showing relief, we also have those that are designed to be fun. Maps produced to promote tourist areas, for example, are sometimes done with a bird's eye view. This is similar to the pictorial depiction of relief that we started with, but the whole map is shown pictorially rather than pictorial symbols on a planimetric map. Here we have Tomlinson's 1899 panoramic map of the Thames and Medway, and the extract shows Oxford. It shows the river and the surroundings only, and looks very inviting. It's a sort of river version of the earlier road or track maps, but much more attractive. This is the 1896 French Alpine panorama, showing mountains on both sides of the road. It appears almost like a reflection, but it actually shows the view you would see in either direction. This is a 1904 example at Yellowstone Park, designed to promote rail travel to the park, commissioned by the railway company, Northern Pacific. A train can be seen in the bottom right-hand corner, and you can just see the smoke actually from the engine. A map surely where cartography and art overlap. This is a glass negative, also produced about 1900, a panorama du signal, showing the town of Lausanne in Switzerland. And it's special as it combines a conventional map, cartouche, and a wonderful panorama. The view is from Signal Hill opposite on the other side of the lake. And a funicular was built in 1889 to get to the viewing point. The printed town plan is for sale with the Antiquariat das Apahor in Munich. And the map shows 79 monuments, tourist attraction, and again, trains running along the tracks. If we go back to the 16th century, maps of towns were almost always done in this way, with a bird's eye view. But that's a whole nother presentation. Thank you. A pity about that. Oh, everybody's gone quiet.
Hello. Fascinating. Thank you very much. We've got plenty of time for questions. Just quick one, Peter. So I did make it clear at the start, you're actually a volunteer at the Bodleian. So how many years have you been doing that?
Ah, that's a good question. I'm not sure. It must be, what, 7 or 8? 7 or 8, I should think.
There you go. Fascinating. Right. So we've got time for questions. About 5 minutes, or probably to make the handover, we've probably got about 3 minutes of questions. So I can't see any yet. Just trying to see if I can see coming up in the chat. No, just really lots of comments saying how fascinating that was. Oh, okay. So can you see that question, Debbie? Or do you want me to read it to you?
Could you read it, please?
Okay, so can you please remind me of the first map to use bathymetric contours in 1580? And that's from Alex.
Oh, One of yours.
No, that was something we mentioned.
Yeah, 1580. Ptolemaic map. Yeah.
Was by a Dutch surveyor. I
Yeah,
don't think we've got the
Ptolemaic.
details because we didn't have an example of the map.
Okay.
The information came from Cartographical Innovations.
Okay, that's all right then. So maybe we can put a bit more detail on a bit later on when we've got more time to research that one.
Yes, we
So
can, is the answer. I've just seen Mary's question, and the answer is yes, we can, but I will have to screen share again.
what's that? Have you heard the term hairy caterpillars?
No, the question I saw was, can we see a picture of Ken's page 228? And actually,
Okay, that's in the chat.
In case it
Yeah.
was needed.
Okay, you find that then. So we do have a question after that about, have you heard the term hairy caterpillar? So we'll answer after you find the picture you're looking for.
Here we are. So that is the Tanaka technique of contouring.
Yeah, so you can see on the right-hand side where the contours have been highlighted, and on the left-hand side, the area is dark around the lake.
Yep.
Rather beautiful, but doesn't seem to have caught on, perhaps because it's difficult to do. I imagine that would be very labor intensive. I think up at the top of the lake as well, you can see quite clearly as the contours sort of go around the corner, they go from light to dark.
Yeah. Okay, so
what was the next question?
Back to have you heard the term hairy caterpillars?
No.
Not hairy caterpillars. Caterpillars certainly, but not hairy ones, if we're still on relief, but it's just a detail.
Okay, another couple one. So why does the topography invert when the light source is from the bottom of the hill shading? Is it because the sun is always above our heads?
Yes.
I think it probably is.
Yeah.
My understanding is that people don't really know quite why, but it just does seem to be what works best. And that was obviously discovered quite early on, because even very early examples of hill shading, they do tend to be done in that way, although it doesn't quite make sense in terms of the actual position of the sun. So that just seems to be the thing that people find easiest to interpret. I think the map behind you, which has some shading, is an example. I don't know if it's really behind you or if it's a background.
No, it's a backdrop. Right, I think probably going to have to close that off now, so we've got time to hand over in time for the next talk. So thank you very much to Peter, volunteer at the Bodleian, and to Debbie Hall. Wonderful talk.